For centuries, humanity has chased gold rushes, from California's hills to oil beneath the earth. But now, the next frontier of wealth isn't on this planet at all. It's out there, in the asteroids. Could these cosmic rocks spark the greatest economic boom in history? In the darkness, deep in the vastness of space, between stars, one fragile world learned to dream. We mapped its continents, traversed its seas, learned to conquer its cloud-dappled skies. But every horizon we master reveals another, just a little further beyond our reach. Now we design futures, worlds we have yet to touch. Join the blueprint. What comes next is ours to shape. Every age is founded on what it can dig up and set on fire. Bronze-armed kingdoms, coal-forged empires, oil-wired a planet with light. But Earth's veins are running thin. Out past the sky lies an ocean with no air, where mountains of metal drift ungathered, silent as tombstones. Fortune has slipped its earthly grave, and the forge of a new economy is waiting in the void. Launching anything from Earth is an exercise in fighting gravity with money. Even with next-gen rockets, each kilogram of payload is still priced like fine champagne. A liter of water in orbit? Over $2,000. A 5-ton truss for a space station. Millions. Multiply that by the needs of future colonies. Air, shielding, fuel, habitat shells, and Earth's supply chain collapses under its own cost curve. That's why every serious roadmap for Mars, for lunar bases, for orbital cities, whispers the same acronym, ISRU. In situ resource utilization. Use what's already out there. Turn the cosmos into our quarry, our well, our power plant. And the richest pit mine in history isn't on any planet. It's the asteroid belt, plus thousands of near-Earth bodies that drift closer than the moon. They hold iron for hulls, nickel for alloys, platinum metals for electronics, carbon for soil, and, most precious of all, water. Locked as ice. Water is life, fuel, and radiation shielding in one convenient molecule. Crack it, and you bottle rocket propellant in orbit for a fraction of Earth launch cost. If we want a civilization that spans the inner solar system, the numbers say we must shift our supply lines off-world. Asteroids come in flavors. C-types are dark, carbon-rich, basically black snowballs peppered with silicates. They can be 20% water by mass and are perfect water stations. S-types are brighter, rocky silicate mixes, shot through with nickel iron. Think raw building stone plus metal for structural beams. M-types are the jackpot, solid metallic cores, fragments of shattered protoplanets. Crack one open, and you might pull out pure iron, nickel, cobalt, even platinum group metals by the 100 tons. One 500-meter M-type could yield more platinum than humanity has ever mined, valued in the tens of trillions at today's Earth prices. How do we mine in zero-G? Forget human pickaxes. We'll send robotic prospectors first, CubeSat scouts mapping composition with spectrometers and radar. Once a claim looks sweet, an autonomous swarm arrives. Some bots anchor with harpoons, others scuttle like spiders, drilling boreholes and feeding powdered regolith into mini refineries. Laser ablation is one elegant trick. Paint a spot with concentrated sunlight or high-power lasers. The surface vaporizes, the plume imparts a gentle push, and the remaining metal condenses into droplets that electrostatic nets can collect. Another idea is optical mining. Wrap the asteroid in a silvery foil of solar mirrors. Bake it until the volatiles boil off into inflatable tanks. For bulk metals, we don't haul solid boulders home. We melt ore with solar furnaces, cast it into slug-sized ingots, then fling those ingots with a mass driver, an electromagnetic railgun, towards cislunar space. Slow, predictable ballistic arcs let a catcher array near the moon snag cargo with almost no extra propellant. The economics flip overnight. A kilogram of water pushed from a carbonaceous asteroid to a high lunar orbit could cost under $50 in energy, versus thousands from Earth. Fuel depots bloom. Deep space missions fill their tanks beyond gravity's toll booth. Companies are already lining up. Planetary resources and deep space industries blaze the commercial trail. NASA's Psyche mission will soon map a metallic world worth, on paper, more than the global GDP. But the true payoff isn't resale on Earth. Flooding terrestrial markets crashes prices. The payoff is enabling everything else we want to build in space. And now a quick word from our sponsor, the drawing board. Because even in the void, civilization runs on support. Still wearing mass-market clothes that say nothing about what you stand for? Meet the drawing board, a collector-driven designer fashion label that fuses future-forward streetwear with high-concept speculative futurism. Every limited edition drop is a self-contained story, bold, intentional, and built for tomorrow. It's not fabric, it's a manifesto you can wear. Try it for yourself, and wear the change you wish to see in the world. Ore and ice are only half the equation. The other half is energy. Clean, constant, scalable far beyond anything fossil fuels ever offered. Without it, nothing moves, nothing grows, nothing builds, but energy in space is different. Solar power satellites solve the biggest problem with renewables, the dark. On Earth, sunlight is filtered through clouds, scattered by atmosphere, and vanishes every night. But in orbit, the sun never sets. A solar panel above the atmosphere receives up to 8 times the energy of one on Earth. Now imagine, not just a panel, but an entire floating island the size of Manhattan, built from asteroid aluminum, unfolding silently in geostationary orbit. It beams down energy not as sunlight, but as microwaves, gentle, invisible, tuned to pierce the atmosphere with almost no loss. On the ground, a rectenna, a web of wire strung across open land, catches the signal and turns it into electricity, quietly, cleanly. No CO2, no turbines, no fuel. The beauty is in the scale. One 5-square-kilometer array could power over 1 million homes. A swarm of them could replace every fossil fuel plant on Earth. And the same arrays can power the factories of space itself. Smelters that melt asteroid metal using only induction. Cryoplants that freeze extracted water into rocket fuel. Orbital printers that extrude kilometer-long girders in microgravity. No scaffolding, no welding, just pure structural ambition. More energy builds more infrastructure. More infrastructure generates more energy. A virtuous loop, an engine of civilization. But why stop at sunlight? Buried in the dust of the moon is helium-3, an isotope rare on Earth, but woven into the lunar regolith by billions of years of solar wind. Just a few parts per billion. But scale it out, and it adds up fast. 1,000 tons of helium-3, harvested with electrostatic brushes, could power the entire Earth for a year, with fusion that's nearly clean. No radioactive waste, no dangerous neutrons, just power, drawn from silence. We don't yet have the reactors, but the physics work. The moon may not just be a base, it could be the fuel depot of the future. And if you look farther still, the numbers start to bend the imagination. A Dyson swarm, millions, maybe trillions of small power stations orbiting the sun, each harvesting a tiny slice of its light. Not a shell, a constellation. Built by robots, fed by asteroids, powered by starlight. Such a swarm could supply 10 trillion times the energy we use today, enough to light cities on Mars, to terraform Venus, to send torch ships between stars. Energy wouldn't just stop being the limit, it would become the catalyst for everything. Terraforming, star probes, entire habitats powered like light bulbs. All of it starts with a single act: catching the first asteroid, building the first beam, lighting the first spark in the darkness. Gold once lured caravans across deserts. Oil redrew maps and toppled kings. Now, silent stones in the dark may bankroll the next chapter of the human story. If we choose this path, economies won't be measured by acres or wells, but by orbits, solar arrays, and the tonnage of metal shepherded through cislunar space. A child born 2 centuries from now may look up at the night sky, not for wonder, but to check stock tickers flashing on orbital markets. Would you stake your future on a claim 1,000,000 kilometers from home? Or does Earth still feel like the only safe ledger? Let us know in the comments. And don't forget to hit subscribe, because in our next episode, we stitch these resources into reality, mapping the starships, skyhooks, and spinning docks that turn cosmic ore into living, breathing cities. This is Architects of the Void. The marketplace of the cosmos has just opened, and the bidding has begun.